Okay, our bells are about to go in school, but I just want to show you something that may or may not help you. So you've got all your notes together. You do know some stuff. You've read Amber Green's your rag sheet. You still might not understand some things, but you have your notes in front of you, and you now have to, work it out in your head. So this is supposed to be messy. It's not supposed to be pretty. The messier it is, the better it is. Each one of you, if you were to do it, it's going to be different for everybody. But you might start with excretion in the middle of your page. You might write your definition for it here. You might decide, okay, where does that bring me? It then might bring me, why am I doing it? So it's bring me to homeostasis. I might write my definition here, or at least say it for myself. I might decide then what's the point of homeostasis. So we've always said something like osmoregulation. We've also said optimum for enzymes, because we don't want them denaturing on us and being inefficient. We might go from there, the fact that we have ectotherms and endotherms. What does that mean? So ecto needs to get its body heat from the outside. Endo, they can make, where endotherms, they generate their heat through respiration. You can even go off into a topic and then have your definition from here and go on to a whole new tangent. Examples of this, reptiles. Examples of this, us, dogs, we're endotherms. We then might decide excretion, what are my organs in a plant? So plant excretion, would be leaf, would be the main excretion organ. It might be then how do they get rid of their products? So it would be loss of leaves, the flowers, petals, bark. That's how they are getting away. What are their excretion products? Technically, they excrete oxygen. They excrete water. They will excrete CO2, and they will have other toxins and things that they need to get rid of. Then for us, it's like what do we excrete, or where do we excrete? So we do it in our lungs, we do it in our kidneys, we do it in our skin. From skin, then we can do what are the parts of the skin. So you might make your list for me. What's the protective functions of our skin? How does our skin do excretion? So that would be the sweat and the salt and the water. So from your protective functions, you might have vitamin D, melanin. You will have the dermis has a protective function. You're going through all of your list of things. So then for our lungs, we're excreting the carbon dioxide and water. You could go down the alveoli route and, do some diagram drawings here. For your kidney, you could decide you're drawing your urinary system. So what are our parts? Or you could list them here for yourself. You could decide I'm going to look at the blood vessels up here. So, we have our aorta, we have our renal artery, we have afferent arteriole and efferent arteriole, we have our renal venules, we have our renal veins. Apologies for the bell. We then would have your vena cava. So there's loads that we can do in terms of this. So then it would be your parts, your kidneys, your ureters, your urethra, your bladder. They would be our parts. We can delve down into the kidney now. What are its parts? So we have the cortex, we have the medulla, we have the pelvis. We then can go into, what's the jobs, filtration, reabsorption. They both do reabsorption down here. And pelvis is your urine collection. We also know that our medulla does secretion, and then it's what secretion. But you can see, just using kind of your word bank, the little bits of knowledge that you have, you can just build what is excretion or what does it mean to you. You can obviously use the rag sheet to do it. You can use the word bank that's on the bottom to do it. And if you can make these links, then that helps you, because you understand your... that's what I'm looking for. You understand this particular topic. There's loads that we can go down here. We can go from our kidney, we can go to your nephron. You can draw your diagram very quickly for yourself. You can talk about, what's in glomerular filtrate versus what's in your urine versus what's in your blood, to just get your head around that. You can go omansa off this. where does most of the stuff get done? We can do my nan served sizzling noodles from it. So very, very quickly you can go through things and talk about what's reabsorbed. We can talk about adaptations. So what's special about your glomerulus and your Bowman's? What's special about your proximal convoluted tubule? There's all these things. So, it's afferent versus efferent is going to be big. The fact that there's loads of capillaries for your surface area. The fact that they're more porous is good. We have Bowman's is 1 cell thick. So that makes that good. Our proximal convoluted tubule, again, is long to give you time. It has the infoldings which allow reabsorption to happen quicker. You can match all of the places on this to their particular job. So obviously this is filtration. Most of this is going to be reabsorption. Actually, all of this is going to be reabsorption. And our little bit of secretion is going to happen here. And it's then what are those particular things. So there's loads you can do, just even using your word bank and your rag sheet and your notes. Obviously, I did this really quickly because obviously I teach it, so I know it really well. And you can go lots of places. As we say, you can go to respiration, you can go to your breathing system. There's loads of different places you can go. Plants, because you love it so much, you can go away on tangents. If you were to do this, it won't look like mine because your brain will process it in a different way, but it will help you to remember things. So give it a go.